Hello and welcome to Maths with Jacob. This lesson will focus on surds. Before we move on to surds, let us revisit the idea of rational numbers and irrational numbers. Let's look at rational numbers first. A rational number is one that can be expressed in the form a over b, where a and b are whole numbers. Some examples of rational numbers are all these numbers here. Whole numbers, decimals, fractions, other types of decimals, recurring decimals, etc. Irrational numbers. These numbers cannot be expressed in the form a over b, where a and b are whole numbers. Some examples of irrational numbers are all these ones here. They have a square root sign, also cube root, etc. Numbers that are preceded by the square root sign are called surds. The set of rational numbers are infinite. As well, the set of irrational numbers are infinite. So the set of rational numbers, when combined with the set of irrational numbers, give us the set of real numbers. These can all be found on the number line. Plotting irrational numbers on the number line. Let's have a look how this is done on the next slide. So, although irrational numbers can't be expressed in the form of a over b, that is, they don't have an exact value, there is a very clever way of plotting them on the number line. So let's have a look. It is important to understand that irrational numbers do not have an exact value. In order to find their position on a number line, we need to go through a very special process involving the right angle triangle and some construction work. So here's a diagram. Let's see what we've done here. In this diagram we have drawn a right angle triangle with base 1 and height 1. So if we pretend that's a part of a number line, and there's 0, we have 1 along here, which is the base of the right angle triangle. That vertical line is also 1. So by Pythagoras' theorem, the length of the red line is the square root of 2. So we have actually found a line which has a length the square root of 2. We place our compass point on 0, there, open it to the length of the hypotenuse and draw the dotted line till it hits the number line. We have found the position of the square root of 2. So you open your compass to that distance, draw the dotted line, and you've actually found the position square root of 2 on the number line. Let's have a look at one more example on the next slide. Finding the square root of 5 on a number line. If we look carefully at the graph below, we can see how to find the position of the square root of 5 on the number line. It involves a clever construction and the use of Pythagoras' theorem. So in a similar manner, we have the base of the triangle is 2 units, the height is 1 unit. So by using Pythagoras' theorem, the length of OB is the square root of 5. Open our compass up to that distance, OB, go around with the dotted line, and there is the position of the square root of 5 on the number line. So this video has introduced the idea of rational numbers, irrational numbers, and surds. And we've also seen, through some very clever construction, that we can actually find the position of surds on the number line.